Hey everyone, so in the last video we described the basic concept behind clean and dirty bond prices, and in this video I'm going to show you an example calculation in Excel, and I'm going to explain also how the price function, because Excel comes with some inbuilt functions that are very useful. I'm going to explain how that works. I'm actually going to show you some documentation on the left hand side of the screen to actually break down how Microsoft explain the terms they're using in that calculation. It wasn't immediately obvious to me whether this was a clean price or a dirty price that they're calculating, all that kind of stuff. Hopefully this will make it absolutely crystal clear. I'm going to give you a demo in Excel of this function, and also a manual calculation side by side, just to show that they're basically exactly the same. And the Excel I'm going to make publicly available on my Dropbox. I'll link the link down below, so you can download it, you can play around with it to your heart's content, and that's it. So let's get started. So Microsoft Excel provides a calculator for calculating bond prices, and before I show you an example of it in use, I want to show you a breakdown of exactly what it does. I'm going to link this down below as well. This is an actual explanation of what exactly the formula is doing. Again, it took me a while to find this and figure out whether the price in Excel is a clean price or a dirty price. Having found this article, I finally kind of understood that it's actually the clean price that it's calculating, and I want to show you a breakdown of how exactly it works, and then I'll also compare this with the calculator on the Investopedia website, to show that they give exactly the same results, and then the Excel example that I show will show you that the manual calculation that shows them to be exactly the same as well. Okay, so basically the calculation that Excel is doing might look somewhat familiar, right? It might look a bit intimidating at first, but essentially you can see what we have over here is the redemption, which is basically the final principal payment divided by this is basically so yield divided by frequency. Let's assume frequency is 1, so annual payments for the time being. So 1 plus the yield to the power something, right? We'll go into this in a second. That's your discount factor. So that's your principal divided by 1 plus y to the power something, plus, right? So we're used to seeing the bond price like PV is first coupon divided by 1 plus y, right, plus second coupon divided by 1 plus y squared, plus the third coupon, right, divided by 1 plus y cubed, all the way plus how many coupons there are. Let's say there are n of them, so plus m plus c all over 1 plus y to the n, right? That's the standard bond pricing formula. It's a geometric progression, basically, that we saw in the previous videos, right? So, and this is actually something very similar. So this part over here corresponds to your m, so your principal divided by 1 plus y to the n, and the only difference down here is that the exponent here, instead of being n as a basically the number of payments, this is basically it's slightly more complicated to take into account the fact that this is now going to be a fraction, or let's say it can be a fraction, right? Because so let's take an example here, right? We've got a bond, and we're basically trying to calculate the price as of 180 days through through a 360 day period, and there are 3 periods remaining, right? So if we break this down, it's basically the price is going to be the redemption, right? So but let's say the redemption is 100, right? So let's say the principal is $100, right? So redemption divided by, so let's say so if we look at the terms down here, so DSC, right, is the number of days from settlement date to next coupon date, which is E minus A, which is the number of days in the coupon period, minus number of days beginning from the coupon period to the settlement date. So that's clearly 360 minus 180, which is 180, right? So that's this period here. This is the number of days, right? DSC. And what we so then we basically and then E is the number of days in the coupon period. So E is 360. Okay. So DSC over E over here, which is a ratio you'll find here, is basically so DSC divided by E equals a half. Right? It's okay. So DSC over E is a half, and this, so N minus 1, so N is the number of coupons, if you see here, between the settlement date and the redemption date. So here we have 1, 2, 3, so N in this case equals 3, right? So N equals 3, DSC over E equals 2. So we discount our principal at basically N minus 1, which is 2, plus DSC over E, so basically 2.5, right? And if you think about it, if you remember, that makes absolute sense, because the time between our trade date and the time that we get our principal back is exactly 2.5 years, right? So that's where that 2.5 comes from. It's basically N minus 1 plus DSC over E, right? So 2.5. So the redemption divided by 1 plus the yield, assuming frequency is 1, right? Then it's just going to be 1 plus the yield to the power 2.5, right? And then for the cash flows, it's basically exactly the same, right? So if I just quickly draw out the cash flows again, so we've got 1, 2, 3 cash flows. Here's our settlement date here, and it was basically 180 here, 360 here, right? So for the first cash flow, this is a sum, right? Sum of all the cash flows. So let's take the first cash flow. So basically, so K equals 1, right? K equals 1. So we're basically saying, so the first cash flow is going to be basically 100 times the rate, right? This basically gives us the actual amount that the bond is paying, right? Divided by, and again, this is the interesting bit, 1 plus the yield, right? Yield over frequency is 1, fine. To the power, K minus 1 plus DSC over E, right? So if you remember, DSC over E equals 0.5, and this is basically what fraction of the period is still remaining between our settlement date and the next coupon date, and that is 0.5 of a period. Okay, so 1 plus y to the power, and K equals 1 for the first cash flow. So K minus 1 is 1 minus 1 is 0. So it's basically 1 plus y to the power 0.5, which is exactly what we talked about before in the first part of the video, where we said we're going to discount this first cash flow at 0.5 of a year rather than a full year, because we've already moved halfway through the year. And if you take the second cash flow, hopefully it should be coming clear now, that's the first cash flow. Second cash flow, we say, so the actual amount that we're getting is still the same, right? It's 100 times the rate, coupon rate, right? Divided by 1 plus the yield to the power. So K equals 2, so 2 minus 1 is 1, plus DSC over E is 1.5, right? So again, the second cash flow, right, which appears here, is exactly 1.5 years away from our settlement date, and that is the exponent that we're using to discount the cash flow. So you can see what I meant when I broke this formula or the concept down at the beginning and saying we're still discounting the cash flows, it's just that we're using a fractional non-integer exponent here in the discount function, right? And it's as simple as that. And then the last thing I want to show you about this formula is that this bit down here is where we subtract the accrued interest, right? And this is where I thought, okay, so this is so clearly, if you remember, price. So this is the clean price, right? Equals the PV of the cash flows, which is basically all of this, what we've just been talking about, minus accrued interest, right? So we have to calculate accrued interest separately. Accrued interest is quite straightforward. Again, it's basically 100 times the rate, so whatever the coupon rate is, multiplied by A. So A is the number of days. If I just scroll up a second, A was the number of days from here to here, so the number of days that have already passed in the period, which is 180, right? So it's 100 times 180, and then divided by E, right, which was 360. E is the total number of days in the period, which is E, right there, right? So basically that gives you the accrued interest. You subtract that from the present value, which is these two terms here, and that gives you the price. And that's what Excel will do, and I'll give you a demo in a second. Now there's one last slight sort of complication here, which is when the settlement or when the trade is happening during the last payment period of the bond. So let's draw the same cash flow diagram here, right? So this is after year 1, 2, and 3. So same, but let's say the bond is traded here, right? So there's only one. So these cash flows are already, they're long gone, right? They're being paid out to whoever was holding the bond at that time. But this, so let's say we're now in the last period, right? In the last period of the bond, of the last coupon period, and the bond is changing hands, right? So there's a slight difference in how we calculate the price. There's only one cash flow to discount, right? There's only one cash flow remaining. So essentially, when we're asking what's the fair price of this bond, we're really asking what's the present value of the last cash flow, right? This is known as kind of like a bullet payment, right? Or so if you look down here, the notes say, so when n equals 1, so basically there's only one coupon payment remaining, then the price is calculated like this. So let's say again, this is 180 days, right, between the last coupon payment and the settlement date. And again, so it's a bit messy, but this is 360 days. So all the periods we've been dealing with are 360 days. And let's say that so let's have a look at how they're doing it now. So discount rate equals E minus A, right, which is, so we know E, so E is the number of days in the period, that's 360. A was the number of days so far elapsed during the current coupon period, which was 180. So E minus A is also 180, right, and that is the number of days remaining. That's the number of days remaining in the period, right? Now, what we're saying is, this looks a bit confusing at first, but it makes perfect sense. So what we're saying is, the price is, we'll have to work backwards. Price equals T1 divided by T2 minus T3. So let's just draw another column here, down here. See if I can fit it on one screen. So basically they're broken down. So T3, so T1 is equals up from up here. So it's basically it's the coupon plus the maturity redemption, right? Coupon is 100 times the rate divided by frequency plus a redemption. That's T1 divided by T2. T2 is and we're just going to simplify frequency equals 1. So we're going to say it's 1 plus ds r over E, right? Times the yield. Okay, that's T2, and then subtract T3, and T3 is basically so 100 times rate divided by frequency is your coupon. So coupon times A over E. So this bit here is your accrued interest, which is basically your coupon period, your coupon payment, which I've simplified as C, is your coupon rate, which is, let's say, 5% or whatever, times 100. Let's say that's your so the dollar value of your coupon rate is simplified as C, multiplied by A over E. A over E is the fraction of the period that's already elapsed, right? So A was 180 days already elapsed in the period, and E is 360. So that's your accrued interest, and then the front term is this is the total value of your last cash flow, because in any bond the last cash flow is always going to be the last coupon payment plus the actual maturity, like the face value of the bond, right? So that's where that comes from. And on the bottom you have 1 plus the DSR over E. Now DSR over E is basically your E minus A, right? It's the number of days, basically, the number of days in the remaining in the period. So DSR over E is the fraction, right? Fraction of the period remaining, right? And so this is basically actually just a very simplified version of this one here, really. But what we're saying is that when the whole number of periods remaining is actually less than 1, right? So in this case, the time remaining to maturity is less than 1 period. It's a fraction of a period. So instead of what we normally do when we're discounting, right, is we say 1 plus r to the power n, right? If the and n is the number of periods that we're talking about. When n is actually less than 1, so when we actually have less than a whole period remaining, we actually write 1 plus r n, right? Because we don't, instead of writing 1 plus, let's say 1 plus r to the power a half, right? Like we did for the previous example, we were writing 1 plus r to the power 1.5 to the power 2.5. But when n is less than 1, then we basically say we just multiply them together, and we say, well, because n is now a fraction of a whole period. And let me just go into quickly why that is, right? So my yield, right, this is my kind of required yield, and we're saying, so the number of days, so DSR, the number of days remaining in the period, so the number of days until maturity equals 180, right? But that is actually only half of one accrual period, right? So when trying to sort of visualize discounting issues, it often helps to sort of turn it back upside down and remember that discounting is really just a inverse of compounding. So the question then becomes, I am now halfway through the year, right? I'm halfway through 1 year. How much, and my interest rate is Y, which I could reinvest elsewhere. How much accrued interest, basically, how much interest could what return could I get by investing at this interest rate Y for half a year, right? Now, I only get my interest rate at the end of the year. So in actual fact, so my future value would be the present value that I invest multiplied by 1 plus Y over 2, right? Because I've actually only accrued half the interest for 1 period, right? So after 2 years, my future value would be PV times 1 plus Y to the power 2, right? Because I've compounded that over 2 whole periods, right? And after 3 years, it would be PV 1 plus Y to the power 3, right? After 3 whole periods, I've compounded 3 times. And after 1 year, in the middle here, future value is the present value times 1 plus Y to the power 1, right? That's after 1 year. You get your full Y is your return. But halfway through a year, you don't write PV to the power, 1 plus Y to the power 0.5, right? It makes more sense to write it like PV 1 plus y over 2, because it's accrued. You've accrued half a period at the rate y, so your accrued interest is basically half of y. So basically, this formula here. Sorry, that's a very sort of. I just wanted to sort of explain in detail what this actually means for those of you who are sort of more detail oriented. That's a breakdown of two separate scenarios, slight variations when the number of coupons remaining is less than one, or sorry, is one exactly, so from the last period, versus if there are more than one coupon periods remaining. And for those of you who are sort of really on the ball, you might be wondering, in the example we talked about before, where the trade is happening with 2.5 years to go, which is here. So this example here, where we walk through the first formula, why do we discount? Shouldn't we discount the first cash flow? Therefore, shouldn't we discount the first cash flow using y over 2 rather than, say, 1 plus y over 2 rather than 1 plus y to the power a half? And that's a perfectly fair point. I think if it was being 100% accurate, you could argue it would be done like that. But the way this formula is calculated is that each cash flow, whether it's the first cash flow or whether it's the second or third, in this formula up here, it's a slight inconsistency. It's not that intuitive. They don't actually discount the first cash flow at 1 plus y over 2. They discount it at 1 plus y to the power, whatever that fraction is. In our example, it was 0.5. So I don't know if that caught anyone's attention, but just wanted to explain that. So I'm going to move on to a quick Excel example, okay? And I think that personally I found it very useful to use the Excel to visualize this. You can see some charts on the Excel as well. So let's go and have a look at that. So I'll put the link to this in my public Dropbox folder down below. If you want to just skip ahead and just download it and play around, then please go ahead. I'm just going to quickly go over basically what's going on in this Excel, so you can actually play around with it. So I've basically created a very straightforward scenario, right, where we have a bond and we have some parameters here. So we're saying we're taking a semi-annual bond, right? It's paying a 5% coupon. The yield to maturity, let's just write that in there just to. So the yield to maturity is 7%, is what we're saying, and we are basically saying that the days in the coupon period are 180. The percentage redemption, so the redemption amount is $100. Face value is $100. The coupon payment is calculated based on the coupon rate, which is the B2, right, and multiplied by the face value, and then the maturity is basically I've just said you can play around with the periods here, right? So you can say it matures after period 1 or period 2, right? And where are those periods? Well, they're over here. Okay, so this table here, don't touch this table at all. This is all pre-configured. You basically it defines it defines 6 possible coupon periods for this bond, right? And based on the period, you can choose which period you want the bond to mature. So if we just say, let's say that the bond matures after period 3, right? The green shading here highlights whether that cash flow is therefore included in this scenario, right? So if I hit 2, then you can see that only these 2 cash flows are highlighted, meaning that the bond is actually going to mature after this cash flow is paid. So each column here, 1, 2, 3, 4, 5, 6 corresponds to a particular cash flow, and basically so you can play around and say you can play around with different scenarios. So let's just say that we're going to have this bond maturing after period 3. So all these first three cash flows are going to be considered in the calculation. And the question is, what is the price of this bond, right? What's the price of this bond on certain dates? And I want to show how the price of this bond changes from day to day, right? Just daily, on a daily basis, all the way up until the maturity, right? So, and the reason is because I want to be able to chart this, and I'll show you over here. You can see I'll zoom in on this later, right? You can, so I'll change the axes, right? But basically, I want to be able to chart what the price looks like on a daily basis, just by as the date moves towards the next coupon date and then towards the maturity date of the bond, right? So that's that. So each row in this table here, right? Each row corresponds to 1 day, advancing 1 day at a time, right? And it's the same calculation each day. And what I've done is I've basically broken down the formulas that we saw in the Excel formula into these different terms, okay? And what I've done is I've taken each of the cash flows, so you can see, so these are the cash flows here. So we say period 1, so this accrual period starts on the 11th of March, right? And it ends on the 11th of September, and the coupon payment is going to be $2.5, and the total payment is therefore 2.5 because there's no principal. The next period begins on the 11th of September, ends on 11th of March. Again, just pays the coupon 2.5. Because we said it matures after period 3, this accrual period starts on the 11th of March, ends on the 11th of September, and it pays $100 in principal, so your total payment is £102.05. And what I've done is, on each of these days, right, I discount and get the present value of each of these cash flows. So this is the period 1 cash flow present value, period 2 cash flow present value, and period 3 cash flow present value. And you can see how these change every day, right? So you can play around and plot whatever charts you want. These are all obviously 0 because I've indicated that this scenario we want to mature after period 3, so these cash flows are ignored. Then what we do is we add the present value of the cash flows together. So let's take the first day, right? So we're saying on the 5th of July 2016, okay, we are midway between the first accrual period, right? So you can see over here, this period column tells us which period we're in, right? So these dates are all in period 1, then we move into period 2, then we move into period 3, etc., etc., right? So basically, 5th of July is midway through the first accrual period, right? And we can see exactly, so it's actually 114 days into the first accrual period, right? So what we do is we're discounting each of these cash flows back from, so that we're discounting the first cash flow from the 11th of September back to the 5th of July, right? Finding the present value, we're discounting it at the yield to maturity, right? If you see the formula here is the exact same formula that we saw in the Excel spreadsheet. Sorry, in the Excel. My apologies. The description for how the price calculation works. Okay, so basically this is the present value of the first cash flow. This is the present value of the second cash flow and the third cash flow. We add those together. Then we calculate the accrued interest. So the accrued interest is basically the you can see how the formulas break down, but it's essentially the coupon payment, right, multiplied by the number of days that have already elapsed in the period, divided by the total number of days within the period, and this gives us this amount, right? So when we subtract the accrued from the present value, we get this. And all I want to show you is, in a nutshell, this is the Excel price function, right? So if you look, so what is the Excel price function? We say, okay, price, and then you specify these parameters, right? The settlement date, which is the date that we're, in this case it's the 5th of July, and that's the day that we're pricing to, because that's the day where we're expecting the bond to change hands between buyer and seller. Then we specify the maturity date, so the date on which the last coupon payment and principal payment are paid back. The rate, which is basically the coupon rate, right? Don't confuse that with the yield. The yield is the next one, so basically what's the yield to maturity of this bond. Redemption is basically per $100, how many dollars are we expecting to get back. So I've basically specified 100 there. We're expecting to get all of the, for every dollar of principal, we're expecting all of it back. The frequency, in this example I've specified semi-annual, so I've indicated 2 there. And the basis, if you specify 0, this is basically the day count convention to calculate the accrued interest and stuff like that. So 0 assumes 30 over 360, which assumes 30 days per month and 360 days per year, right? I just want to basically point out that this is my manual calculation down here, and I do encourage you to sort of download the spreadsheet, play around with it, and basically compare and see for yourself that the price function that Excel is providing is actually doing exactly what it says, and more importantly, the price function is giving you the clean price, right? It's present valuing the cash flows. It's subtracting a manually calculated accrued interest, and that's the price function, right? And then what I want to do sort of last of all was basically to show you the bond calculator on Investopedia as well. So if you can see, again, I'll link this one down below as well. And again, I had a tough time figuring out initially whether the Investopedia price was giving you a clean price or a dirty price. Turns out it's also giving you a clean price, right, or a quoted price. I just want to show you the parameters, and the price comes out the same. So if we can see, we've entered the same details. So par value $100. Settlement date is the American date convention, 5th of July 2016. Maturity date is the 11th of September 2017, right? It's that one there. The annual rate, coupon rate is 5, right? That's that one there. The yield to maturity is 7, right? And you can play around with these numbers as well, right? I'm just giving you an example. Redemption value is 100, so you're going to get all of every dollar of principal back. You're going to get it all. And semi-annual payments. So basically that's the same as our frequency over here. Hit calculate, and down here you get $97.76. And if we go over here, Excel price function. So now we've got our three prices, right? And they're all the same, right? So this was the Excel price function, 97.75. So Investopedia, they rounded up. This is my manual calculation, and it's exactly the same as the Excel one. So in a nutshell, if you want to play around and sort of understand how the Excel price function works, you've got a tool now to do it. Please download it. If you have any questions on how to use it, let me know. You've also got access to the Investopedia calculator, and you know that this now is definitively giving you the clean price, not the dirty price. And if there's one message that I really want to sort of take away from this video, it is that the process of the seller of the bond being compensated for the accrued interest that they've accrued between the last coupon date and the settlement date, that compensation is something that's implicit in the dirty price, right? It's already in the dirty price. When you discount the cash flows and find out how much that bond is worth, because as you get closer and closer to the next coupon date, right, the next coupon is being discounted by it's being discounted less, right? So the value of that first cash flow that is actually approaching the amount of the coupon, right? So the point is, the buyer of the bond is actually, as each day goes by and gets closer and closer to the next coupon date, the cost of the value, and therefore the cost of that first coupon payment, is getting bigger every day. And that is basically, that's how the seller is being compensated for the accrued interest, because because they're getting more as each day goes by, and they sell the bond closer and closer to the settlement date. Yes, they've accrued more interest, but the seller is paying more in terms of the present value of that cash flow, right? So there's no separate transaction that goes on. There's no kind of, oh, you know, let's find out what the fair price is, and then, okay, let me invoice you separately for the accrued interest. That doesn't happen. It's basically the transacted price is purely and simply the present value of the cash flows that the seller, that the buyer of the bond will receive, right? It's as simple as that. And I did mention the graphs, right? So you can obviously the beauty of Excel, showing the movement of the price of this bond as we move from the 5th of July 2016 all the way up to the maturity date. So let me just show you this quickly. So what I've done is I've populated two column values. I've plotted them against every date from the 5th of July all the way up until the 11th of September down here, right? And this is, I think, obviously sometimes it helps to see a picture, and if we see that the orange value here is the dirty price, right? And this picture tells a lot, right? So the orange value basically tells us that what the present value of all the cash flows of this bond are, right? And as I mentioned before, the present value, so on the 5th of July 2016, we have three cash flows remaining, right? We have the one that happens on this date, the one that happens on this date, and the final one on this date. And the value of that cash flow, the first cash flow, right, increases until the day it's paid out. And then after it's paid out, the value of the bond basically crashes by the amount of the coupon, because we no longer have that coupon in our present value, right? It's already been paid out. So that leads to a kind of sawtooth pattern in the dirty price. So, and that's what I'm saying, if you want to actually, if you want to study the price of a bond over time, or if you want to compare, for example, this bond with another bond, right? Just because if you compare the dirty price on this day and this day, there's a massive difference. And often, but you know, normally when bond prices shift between one day or in the next, it normally means that, you know, something the market is not, you know, looking favorably on something about that company. Purely because a coupon's been paid here, the price is basically just dropped off a cliff here. So that's why the dirty price is not really suitable as a sort of benchmark for comparison between this bond and other bonds, because we have this sawtooth effect. If you see the clean price, which is at every point, what we've done is we've subtracted the accrued interest, right, from the dirty price to give the clean price. You can see it's on a beautifully smooth upward trajectory from the initial clean price on the 5th of July all the way up to 100. And lo and behold, this is why when they say that the clean price of a bond moves towards par as it gets closer and closer and closer and closer to the maturity date, and that's because in the last period here, right, we only have one cash flow remaining, and the value of that cash flow on the day before we receive it is actually very close to the value of the cash flow itself, right? It's very close to the amount of the cash flow. The value of the cash flow on the day before or the day before that, as we get very close, you're discounting by a very, very small amount. And that's why we see that the clean price of the bond basically tracks this kind of nice, gentle upward trend towards the par at maturity date. And I think so. I just wanted to show you that. You can obviously plot other stuff on this graph as well, but this is in a nutshell why clean prices are quoted in the newspaper, for example, because the dirty price is basically it has this element of noise on top of it, which is the cyclical accumulation of accrued interest, which is then paid out and then begins to accrue over the next period. So yeah, that's a breakdown of clean price, dirty price, accrued interest. If you have any questions, let me know. It is quite tricky, I think, some of this stuff to understand, you know, which comes first, the clean price or the dirty price. So, you know, I hope this was useful. If you do have any questions, then please, you know, please let me know. I'll try and clear them up. Please download the tool, have a play around with it, enjoy it. And I think in the next video, we're going to start talking about sort of yield curves and that kind of stuff. Because we've talked a lot about yields now, and yield curves, I think, is the next logical step. So thanks for watching, and I'll see you in the next video.